Okay, so what's in the session today? We're going to be working with classes and objects. We're going to be doing some more library stuff. You should have covered libraries last week with AI. And we're also going to discuss readability and how to write readable code. I'm just going to note that I'm only going to be presenting on classes and objects because that's kind of the hard bit. Library stuff you've already covered. We're just recapping it essentially and dealing with a couple different libraries. And also readability, we've already got really good notes on that. Library stuff, we're recapping it because it's quite important. If you deal with Python a lot, then the majority of your code is going to be dealing with libraries that have already written stuff for you. You're rarely going to be writing things from scratch. Okay, so objects and classes. What actually is an object? And another question might be, how do you use them? Another question you might come up with is, why would you even use an object in the first place? And these are good questions. So to explain them, to explain the answers to these questions, we'll dive into an example. And we're going to model game entities as objects as our first example of objects. So what do I mean by modeling game entities? I mean enemies like bandits, killable things, basically. Things with health. So entities have data. So for example, health is a piece of data about an entity. And this is called the state of an object. So a game entity might have health, they might have speed, they might have stats like strength. And entities also have actions associated with them. So this is called the logic of the object, or the operations. So the idea of objects is that we're bundling logic and state all into one neat little package. So actions might be eating, casting spells, even things that the entity you might not think of as doing, but for example, if you're dealing damage to an entity, you might use an operation there. So why use objects in the first place? Having state and logic together is a really nice way of bundling things together because it just is easier to write readable code. And you'll have to deal with objects anyway because Python is littered full of objects. If you're writing any serious Python code, then you're likely going to be using libraries, and libraries will basically always use objects. Okay, so we're going to discuss how to actually make an object, and we have to write a class first. So classes tell us how to make objects, and some people think of classes as a blueprint. So it describes how to make your object and describes the logic that the object can actually do. So here's an example of creating an object in Python. Note the class keyword and then this funny little method called init, which is short for initialize. The special thing about this is that this is the constructor method. So this is a special function which is called whenever an object is created. So whenever an object's created, it calls this special function, and you can tell it's special and you can sort of remember it by the fact that it's surrounded by underscores. Those are 2 underscores, by the way, on each side. And it's called a constructor. So this is the code. The formatting's changed, but it's still the same code. So it also sets the state in this specific case. Constructors don't have to set state, but they almost usually always do. And this is an example of setting state. So these variables are called the attributes of an object. So in this case, health, max health, and speed are all attributes, and they describe the state of the object. So you might be asking, what is self? Just to remind you, self is this parameter here in the init function. So self is just a variable for the object being created. So it just refers to it, and every operation you define gets given self automatically. So the init operation, the special operation which constructs the object, that gets given self. Operations are implemented as functions, and we call those special functions methods. So it's kind of a difference between the theory and the implementation, right? So they're called methods when you actually write them as functions, but sometimes when you're not specifically implementing them, you discuss them as operations. But there are many different terms used in object-oriented programming anyway, just to let you know that these are terms that are used. So this is an example of writing our own method, which isn't a quote-unquote special method. It isn't called when the object's created or anything like that. It's a method that we have to specifically tell the class to invoke. So we can see that self gets passed because self is passed to every method, and we can see how we can access the attributes of self here. So to illustrate this further, we're going to add some stuff in the constructor function. Some people get confused and they think constructors are just for setting attributes. You can do basically anything in a constructor if you wanted. So just remember that you can do other things as well. So this is an example of actually creating an object, and this also has a fancy name. You can just think of it as creating an object, but it's also called instantiation or instantiating an object from the class. And note that constructors automatically return the object. And we also have this same type of thing with calling a method. So you'll notice that with the constructor and the print health method, both methods, we don't actually call it with anything, but it still gets given self. And that's because Python automatically adds self as the first argument. And similarly, it automatically returns the object as the argument to the constructor. So this is the output. And this is what I talked about just now, is that self is automatically supplied by Python. So we'll define a new method to illustrate this, but this is essentially what I've been talking about anyway, with a couple key things. So obviously we can modify attributes, and the interesting thing is that we can call the other methods in the class or in the classes that the objects are part of inside an operation. So we can use other operations inside the operation. And we can also call this method, and the interesting thing about this is that it has an actual parameter other than self. So we've added parameters to to regular methods, but we can also add them to the special methods, right? Like the constructor function, we can add parameters there. So then we'll see that we should get 20 out of 30 as the output because we started with 30 health and we dealt 10 damage. Okay, so let's examine why objects are convenient. So we talked about before, I just kind of said that objects are convenient, but I didn't give a great reason why. And the alternative is essentially just creating your own objects, but without making them classes, right? Like using dictionaries. And the con of this is it's a little bit more awkward to do. And also, you no longer have object checking anymore. You only have, you just don't have the validation anymore. So if you try and pass a method, something which isn't an object, then it will probably error because the method might try and access that like a specific attribute, and if it's not there, then your program will crash. So it's just easier to code because you have to code your own input validation to the methods. And also, it just looks a bit more confusing. And one of the key things is there's no autocomplete. So one of the strengths of using OOP, especially in libraries, is that libraries will use, whenever you're using a new library, autocomplete from Python IntelliSense is just very useful. And if a library was created without OOP, then it wouldn't know which methods corresponded to which objects. So specifically putting the methods inside specific classes is very useful. Another thing is that everything in Python is an object pretty much, so you'll be dealing with objects whether you know it or not. And by everything I do mean basically everything. So not just the class that we've created ourselves, but even strings, even just normal numbers like integers. And we can see this using the class attribute. So init was a special method because init, and it was denoted as a special method because it had underscores around it. Similarly, we have special attributes that we don't directly write to usually, but these attributes are sort of baked into the language and they have underscores around them. You can set underscore class underscore for your objects though if you want to give it a specific readable name. And this is pretty useful because you can compare things and you can check whether a given object is of a certain class. So this is the output, and you can see usually underscore class underscore doesn't have a very readable name. So you might want to give it your own if it's useful for you. So that's the end of the slideshow. That's pretty much classes and objects in a nutshell without some of the more complicated things like inheritance. And this should be enough to get you kickstarted on the exercises. So again, Google Drive, you should be able to find the resources there.